Recursion can be a abstract way of seeing the world if you try and solve it as a big picture or try and solve it as a small picture. So I want to show you how recursion can kind of be a little bit naturally intuitive if you can kind of set your focus, and I mean that figuratively and a little bit literally, at the right depth of field. So for example, dealing with file systems and files is naturally recursive because file constructs are also naturally recursive. When you deal with files, which you probably have working with computers, for a long time, you start working in some directory. And sometimes that directory might be the start of a hard drive, your C drive, your E drive, or whatever your operating system calls it. But most of the time, you just get dumped in some folder. And in that folder, you have this recursive view of the world because you have a very limit. You don't see everything. You have a very limited view. In this folder, you can see I have files and I have subfolders and I have parent folders. So I'm in the recursion folder, and that's part of the learning Python package. And so the great part about recursion is I don't have to have that global view of everything. I can just deal with the fact I have a parent folder, I have child folders, and I have stuff that's in my folder. And I can find out everything I want to by basically creating a set of functionality for me that I can also have that parent or that child execute in the same way. And mostly we're going to talk about children, not parents when we talk about recursion, but it's not impossible. You can recurse backwards as well. So the file system query is the one we're working on now. I have that file open. And we have some real simple questions like, hey, how many subdirectories are in this folder? Now, this is a question that you can answer without recursion. So the really important thing here is we're practicing recursion now. There might be some looping that we're going to do inside of it because that's what Python does. But we need to remember that our main goal is to do this recursively. So before we try and go to the whole problem, let's understand just how do we recursively walk through a directory structure? How do we even access directory structure in Python? Those are all good questions to ask. So you can see here in our little test, there's asking for us to check out this file test. That's this folder structure right here. And so it's probably worth going and take a look at that. So when we look at file test, we can see there's three folders, A, B, and C inside of file test. And then in A, there's a couple files. And in B, there's a file and another folder. And that one has a file inside of it. And in C, there's a file. So it's just some random assortment of files inside of a directory structure. And so the answers that we're going to get back is going to be based off of this little folder structure here, file test that we're going to ask. And so when we ask the number of subdirectories, we're looking for the answer 4 because there's 1, 2, 3, 4 subdirectories inside of there. All right. So again, recursion is about base cases and about recursive cases, but let's just start even simpler than that. If sometimes for me, if I have to start thinking in terms of breaking down the problem, I don't even know what to do, where to start. And so I'll always recommend if you want to code anything, just start with what you know. Start small and inch towards the answer. So we're going to start number of subdirectories. Well, let's say, well, how do I even know what files and folders are in a current Python, you know, folder file you're given. So we're given the start directory. Let's look at the contents of that start directory. Well, in Python, I can say for an item in the subdirectory. That's the variable I'm going to name for it. Inside of this OS, so it's something we reported here, operating system, OS dot list dir. So list what's in this directory. I'm going to give you a directory right now and what's inside of it. So I say start directory. Okay. And all I'm going to do is say print item. So I don't need to start fancy. I don't need to start even solving the problem. Let's just see if I understand how in Python I can loop through the contents of a directory and see what's inside of it. Now notice, in this case, I'm using a loop to get started, and I'm going to allow the loop in this case because it's important and it's useful. Oop, invalid syntax. What did I do? Is in. I spelled it wrong. Didn't see it for a second there. In folder. All right, there you go. So, excellent. I didn't pass any of the tests, but I don't care. All I want to do is I printed A, B, and C, which comes back to file test. You can see I can see A, B, and C. So this line of code is something, if you didn't know this line of code, you could have Googled it real quick. How do I, or whatever your search provider preferred is, how do I see the contents of a directory in Python? And you'd find this is one of the answers out there. So now that I have, that, and I have the ability to see each one of the things, I want to be able to count if it's a subdirectory or not. So how do I know if the thing I have, the item I have, is a subdirectory? Well, again, I can Google that, but I'm just going to give you the answer in the interest of time. So if os.path is directory. All right. So I can say is the item a directory. I can say okay, print. Uh, oops, it's a directory. I'm going to put a colon right there. So the next thing. So let's see if this works. So for each item in the path, I'm going to print it out. But if it's a directory, I'm going to print out it's a directory right before it. So let's see if that does it. Oh, none of them showed up as directories. But wait, they are directories. A, B, C. It showed that. So well, what happened, right? Why is that wrong? Well, again, this is a case where a little bit of Google searching if you're building it for the first time, a little bit of reading or asking the right person at the right moment is really helpful. What you have to understand is the item itself. Let me show you real quick. The type of the item here. Let's look at that. Is a string. What is directory is expecting right here is a full path. So it doesn't know where that directory is listed. It doesn't know what it is. So it's not a directory as far as it's concerned. So really what I want to do is I need to see the full path. Okay. And that's going to be a joining of the start directory and the item. And so when I look at the full path and check that, that will actually give me an indication of is it a directory or not. So let's check that out. Ah, there you go. So there, A is a directory, B is a directory, and C is a directory. Much better, much better. So I have a better indication of what's going on. I have moved on. So right now, I've done zilch recursion. Nothing. It's okay. Um, because I need to do this loop to be able to, recursion isn't I hate loops. I never want to do loops. I need to do the loop because it's the best way to be able to look through the directories I'm given the path. But what I have done, I figured out this is a directory. So what I can do is say, okay, well, count is equal to count plus 1. Because that's my goal here is I want to count the number of directories. Okay, so now instead of returning 0 every time, which I've done, I can return more than 0, but I'm still not quite there. So a result didn't match. I returned 3, but I expected 4. Well, why? Because I have 3 right here, but there's a 4th directory, D, inside of B. Because we're not just simply saying how many subdirectories are directly in this folder. We want to know how many subdirectories are entirely in all the subfolders inside of here. So it's kind of like saying, how many rooms are in the building? Well, if I only account the number of rooms in that hallway, it's not answering the whole question of the whole building. I have to check that hallway and the next hallway and the next floor and the whole building, right? And so that's where recursion comes in. So if I ask you the question, how many subdirectories are in a specific directory, and I return the count of directories in that folder, and then I add that to the number of directories in that directory, right? Then I can get the whole answer. So in this case, our recursion is actually insanely simple because you tell me where to start. right? So you say, okay, I'm going to walk you into a building and I'm going to put you in a hallway. And how many rooms are in this hallway? One, two, three, four, five. Okay, five. Well, let's just say how many doors. Let's just view it that way. I don't know how many. There could be rooms behind rooms, right? So I see five doors, and so then what I do is I put you in behind that door and say, well, how many doors are here? And then you go to each of those doors. You enter each of those doors, right? And you keep counting them up. So to add the recursion in this case, I don't have to worry about base cases because I know the nature of file systems is every time I go through the door, in the file system, I'm not going to end up where I started. I'm not going to end up looping back around in a folder I started with. So what I can do is I can say, well, let me add in the number of subdirectories for the full path, the one that is a directory, right? So let's check this out real quick. Let's go ahead and run this. I'm going to leave my print line here intentionally and see what happens. Oh, interesting. I passed that first test. So I started and I saw the first thing I saw here was one.txt. The second one I saw is four.txt. The third I saw was A. And then I saw two.txt. And then five.txt. And then I saw D. And then I saw B. And then I saw three.txt. And I saw C. So it's interesting. When I look at this, what happened? It's worth taking a second to explore that. So my code was given file test as a directory, right? It goes into file test then. And it says, okay, what's the full path of each one of these? So it starts with A. So what's the full path? It's file path slash A, right? And is it a directory? Yes, it's a directory. So I'm going to count one to that and add in a recursive call to check out A. So we go into A, and then we call number of directories on A. Well, we haven't printed anything out yet. The print line comes much, much later, right? So I come in here and I say, well, what's all the files in this one? Well, I have 1 and 4. So I come and look at the full path. Okay, is it a directory? No, it's not. So I print 1. And that's what I saw here. The first one got printed. And then I go to the next one inside of the list and it's 4. And that's not a directory, so I print 4. And then since I'm done with the list, I return 0 because there was no directories inside of here. Count was 0, I returned 0. That's what happened right here. And then when I return, I'm actually right at this point where I was dealing with A. And so I add 1 to A, and then I print out A, and that's where A comes in. Now, if you don't see all this, it's a little bit complicated. We can simply add in here the count. Let's run it again. All right, so now you can see the count was 0, the count was 0, and then here when I print A, the count is 1. And so then I come around to B. Now, again, if you don't see it, add more printing here. And I'm actually cutting this short. You might see it just fine because this representation is a model of what's happening in your code. And it doesn't necessarily mean that these two things mesh. And one of the tricks on recursion, and all code, by the way, this is just a debugging trick, is keep adding print lines till you understand what the code is doing and what you're seeing. So let me do it one more time here. So you can see we pass in file test. Right, so the very first call, very first line of code right here. I turn on my line numbers here. Line 9, I print file test, and then it goes through and it starts navigating the directories. Again, if you don't see it, add in a print line. I can say print item here if you want to before you do that. I'm not going to do that right now, just to keep it simple. So then I navigate into the call right here, and then I go to this line and it says, oh, file test.a, and that's where I print 1 and 4, and then I come back from file test. I return count. If you're not sure, you can always do a print right before the return and say this is what I'm returning here if you're not sure what your recursion is doing. All right, and so then I have my count of 1 right here. And then I go to B and I call into B and I print out 2, and then I see D as a folder and I go into D and I print the 0 of D because there's only one the file in D. And then D has size 1, so I print that. And then I return the B. So I've recursed twice inside of there. When I get to B, I come back into B, and I notice I jumped from 1 to 3 because A added 1, B added 2, D added 3. And then I go into C, and then I add in C, and then I get the right answer. All right, so I'm going to leave this here for a second. Hopefully you can get this one built. And then we'll take a look at the number of files next. But maybe if you got this one working, give it a shot. Get started, and we'll see if what you got started with aligns with what we'll come up with next.